Balancing equations is basically the chemist's version of the game solitaire. And in fact, in the Journal of Chemical Education, they published, just as a challenge for fun a few years back, a bunch of very challenging equations for chemists to try to balance. And some of them are really, really heinous to do, the balancing. We won't be giving you any of those in this class, but balancing equations can actually be a little bit of fun if you're approaching it as a bit of a strategy game. Now, let's look at a strategy for solving these problems that'll make it less annoying and more fun. Now, the first thing you need to do is translate the statement. What I mean by that is, remember, usually we're talking about things that are word problems when we're talking about chemistry. Because most of the time, if you're working in a laboratory, the lab manual is going to be telling you to do something. You've planned out a reaction, come up with an experiment, you're working up your results. You're going to be converting from words into numbers or symbols. That's going to be what's happening here. So if we tell you solid aluminum reacts with hydrochloric acid to form dissolved AlCl3 and hydrogen gas. From that, we're going to need to be able to translate what all that means. Now, some of this has a bit of nomenclature, and depending on the sequence, you may not have had that nomenclature, but we'll talk through that right now. And of course, if we haven't covered it in class, you won't be responsible for it yet. Now, solid aluminum. That's telling me that it's going to have Al. We know that a metal is by itself, unless we specify that it's like aluminum oxide or something. So it's going to be aluminum solid. You can see that right there. It's going to react with hydrochloric acid. Now that's a bit of nomenclature, and that means it's going to be HCl dissolved in water. If you're doing it, if you've had the nomenclature and you haven't had the acid nomenclature yet, you might be looking at that and saying, this is going to be hydrogen chloride, opposite sides of the periodic table. And so you'd be right about that. It'd be hydrogen chloride. Once you put hydrogen chloride into water, it acts as an acid, at which point you switch to your acidic nomenclature. And if you've had that by now, then you know that the name for that will be hydrochloric acid. So HCl, it's dissolved in the water, which means it's aqueous. Now notice it says to form. That means that this is going to be the moment where we switch from reactants to products. And we're going to form dissolved AlCl3. It's dissolved. That means it's going to be aqueous. So AlCl3, aqueous. And hydrogen gas. So hydrogen, we have to remember to pay attention to our octet rule and all that. We say, well, it's not just going to be hydrogen atom. It's going to be H2. Each of those individual hydrogen atoms brought one electron. By combining two of them together, we got a duet. And for hydrogen, 2, a duet, is enough. It filled up the 1s orbital. And so we end up having H2 gas. Make sure that you remember to do it that way. If you start writing atoms when you should be writing molecules, that'll be a problem. And you see that we've had a couple of cases like here and here, where both of those were important to think about. Now the next step of balancing our equation, now that we've translated the statement and we know what we have and which ones are going to be the reactants and products, we've got to actually go ahead and lay them out with that arrow. And remember I said to form or to yield. That tells you it's time to write your arrow. So we've written it all down. But notice, I have one hydrogen atom on this side and two hydrogens on this side. I've got one chlorine and three chlorines. That's a problem, and we're going to need to balance that. So next thing we're going to do is balance our atoms. Now, here's some strategy that you can use to try to make that an easier process. Notice that I can put whatever ratio I need in front of aluminum. I can put whatever stoichiometric coefficient I need right here. And since there's no multipliers, it's going to be something I have total control over. I can pick any whole number I need very easily. However, notice that over here we have something a little more tricky. Every time I change how many aluminums I've got, I change the number of chlorines as well. In other words, every time I make a change, it could impact something else in my reaction. So the best thing to do, start out by trying to balance your most complicated molecule. Work toward the one that's most simple. I don't mean like work individually. I mean start with the most complicated, go to the next level of complexity, finish with the least complex, because that's the one that's easiest to fix at the very end, right? So let's take a look at that. Now, what just happened there? Well, what I did is I started saying, well, okay, suppose that I've got AlCl3. I need to get more of these, so let's just work it backward. I'll start out with maybe H2. Since I've got H2, I'm going to need 2 of this one. Now I've got my hydrogens balanced out. 2 chlorines, 3 chlorines. All right, so let's do times another 3 here. Let's do it times 4 here. Or no, by 2 here. And then, let's see, I have 6. I could do a 3 here. Aluminum, I've got 2 of them there. So you can see I'm going back and forth. Wait a second. Depending on how you approach the math, however I did it here versus the way I just showed you right there, and I know I went through very quickly. Don't worry, we'll see some slower versions very soon. But notice, the ratios are still about the same, right? It's 4 to 12 to 4 to 6. This is 2 to 6 to 2 to 3. That's still the same ratios. We've just reduced it to a lower common denominator here, right? Well, that's what we're going to have to do, is adjust our coefficients, because there's lots of ways to solve these problems. I mean, maybe I ended up having 40 aluminums to 120 HCl's to 40 AlCl3s to 60 H2s. Depending on the little tricks you're using going back and forth, you commonly will end up having some multiplier too many. Now we're going to adjust it down to get what we had just come up with as a final answer right down here. So we've adjusted our coefficients. Now we're going to check to make sure that we have a final answer. Here's how I like to do this. I'll write down all of the atoms that I've got on each side. Now what I'm going to do is say, how many do I have? Well, I've got 2 aluminums. I've got 6 hydrogens. I've got 6 chlorines. So 2, 6, and 6. Over here, I've got 1 aluminum times 2, so that'll be 2. I've got 3 chlorines times 2, so that'll be 6. And I have 3 times 2, giving me 6 for that. These numbers are all the same, and so it is balanced. And actually, you probably are going to set up a table like this while you're balancing your atoms, because it really ends up being a helpful thing to do, to keep track of where you're at. And what I'll do is I'll just kind of cross things off and update numbers as I go. Okay, so that's how we're going to be balancing chemical reactions. Now, I'm going to go ahead and erase all that. If you haven't done it already, at the end of balancing, make sure that you specify your states of matter when you know them.